want to request Dr. Namitha to share her presentation and unmute herself.
Hello, myself Namitha R. Going to present my work Synthesis, Characterization and Applications of Novel Thiazolidinone Derivatives. Introduction. Heterocyclic compounds are important part of chemical science. Also, sulfur and nitrogen containing heterocycles exhibit notable medical and pharmaceutical properties. Sorbinil, a commercial drug containing thiazolidinone moiety, is very important drug for anti-diabetic potency, and literature survey revealed that they have anti-diabetic, antimicrobial, anti-tubercular, antiviral, analgesic, anti-inflammatory, anti-tumor, anti-Parkinson activities, as well as non-linear optical properties. So I decided to synthesize and characterize 3,2,4-dinitrophenylamino, 2-methyl 2-phenylthiazolidine 4-on and its derivatives using IR, proton NMR, and C13 NMR spectrum. And also to evaluate the pharmacological potency like antibacterial, antioxidant, and anti-diabetics of the same compound by using suitable methods. Also, I decided to determine the nonlinear optical property of the compound by in silico method by using Gaussian line software. Experimental part involves two stages. First one is the synthesis of shift base from the starting compound 2,4-dinitrophenylhydrazine and acetophenone. Here, equal moles of 2,4-dinitrophenylhydrazine and acetophenone were stirred for 1 hour by using ethanol as solvent. In the first step, synthesis of shift base. Here, shift base was synthesized from the starting compounds 2,4-dinitrophenylhydrazine and acetophenone. Equal moles of these compounds were stirred for 1 hour by using ethanol as solvent. The progress of the reaction was monitored with TLC. Recrystallized from alcohol. The product obtained was recrystallized from alcohol. Melting point and yield were noted. Here, the yield percentage is 82% and melting point was 228 degrees Celsius. After getting the shift base, we cyclized the shift base by using thioglycolic acid as reagent by cyclocondensation reaction between shift base and thioglycolic acid. Here also equal moles of thioglycolic acid and shift base were refluxed for 9 hours by using chloroform as solvent. And the progress of the reaction were checked with the TLC by using silica gel. And melting point and yield were noted. This is the result and discussion and the reaction condition, and the reaction sequence was here depicted, and IR spectrum of the shift base was recorded, and the IR peaks were noted here. Peak at 3,300 centimeter inverse is attributed to NH group, and 3,113 for aromatic CH stretching, and CN stretching was observed at 1,612, and C double bond C stretching was observed at 1,583 centimeter inverse. Here, aromatic CH stretching was aromatic NO2 stretch asymmetry stretching was observed at 1,413, and 1,490 attributed to aromatic AR-NO2 symmetric stretching. Then this is the cyclized product, and the reaction sequence was depicted here. Here also the product, the final product, the thiazolidinone. For the final product also, we recorded the IR spectrum. IR values were noted, and the peak at 3,300 centimeter inverse indicate the presence of NH group. Also, aromatic CH stretching was observed at 2,924 centimeter inverse, and CN group observed at 1,640. C double bond O group in the thiazolidinone ring was observed at 1,710 centimeter inverse. Again, CSC stretching bending observed at 835 centimeter inverse. Aromatic NO2 stretchings were observed at 1,413 and 1,489. This is the proton and C13 NMR spectrum of the synthesized compound. Here, a 3-proton singlet observed at del 2.5 indicates the presence of CH3 group in the molecule. Here is a CH3 group in the molecule. At multiplet in between del 7.1 to 8.3 is attributed to 8 aromatic protons in the aromatic ring. Again, del 9.1, a singlet at del 9.1 indicates the presence of NH proton. Del 11.3 and del 3.64 for OH protons, CH2 proton. Again, C13 NMR spectrum were also recorded here. CH3 carbon atom observed at del 13. In del 77 to del 145 indicates the presence of aromatic carbon atom, and del 152 indicates the presence of C double bond or carbon atom. Here del 33 indicates the presence of CH2 group in the molecule, CH2 carbon atom in the molecule. From above all data, we finalize the structure of the synthesized compound as 3,2,4 dinitrophenyl phenyl amino, 2-methyl, 2-phenyl thiazolidine, 4-one. Moving on to the pharmacological applications, pharmacological studies were done. Here, antidiabetic, antibacterial, antioxidant activity of the synthesized compound were recorded. Antibacterial studies of the synthesized compounds were noted against E. coli, SORS, Klebsiella, Pseudomonas sp, etc. Evaluation effectiveness of compound were tabulated. Here, we noted that higher concentration of the compound resulting in large zone of inhibition. Antioxidant activity, we evaluated the ability of the compound to scavenge the also increases. This is the antibiotic inhibition of alpha amylase activity by the compound, suggesting its potential as a therapeutical agent to regulate the postprandial glucose. If concentration increases, then the percentage of inhibition also increases. Then computational studies. All the calculations were done by using Gaussian 9 package of soft programs. The geometry of the compounds were optimized using B3L by P with the 6-31G D, P basis set. The computational studies give NLO properties of the compound calculated by using first order hyperpolarizability. This is the geometry optimization parameters and the calculation and the equations used. This is the result for polarizability, hyperpolarizability, etc. Conclusion: 3,2,4 dinitrophenyl amino, 2-methyl, 2-phenyl thiazolidine, 4-one were synthesized. The precursor 1,2,4 dinitrophenyl phenyl 2,1-phenyl thiazolidine hydrazine was obtained by the reaction between 2,4 dinitrophenyl hydrazine and acetophenone. The synthesized compounds was characterized by using IR, proton NMR, and cytidine NMR spectral data. The antibacterial, antioxidant, antidiabetic activity of the synthesized compounds were also studied, and the results were found to be active. And a nonlinear optical activity was analyzed from its first order hyperpolarizability and compared with that of standard urea. The UVPL spectra were also recorded, and from the peak value, the theoretical predictions were well in line with these results. The compound exhibited high nonlinear optical character, thus can be used as an OLED material in future. Thank you.
Thank you so much.